This is the tutorial video for the Unit 3A retake practice. Number 1, complete the square. X squared minus 4x. So to fill in this blank, we want to take half of b and square that value. So that would be negative 2 squared, which is 4. Number 2, convert y equals x squared plus 8x minus 3 to vertex form by completing the square. Completing the square is using this process that we did in number 1 so that we can factor it as a perfect square. So your first step is to write out the equation, leaving a blank to create the perfect square. So whatever we add in the parentheses, we also have to subtract at the end in order to keep the equation balanced. So using that same strategy, I am going to take half of b and square it. So that would be 4 squared. So 16 is what goes in both blanks. Now I rewrite this line by factoring the perfect square and combining the constants. Number 3, given the quadratic form, the quadratic function f of x equals parentheses 5 parentheses x minus 3 squared plus 7. I'm describing all the transformations from the parent function. So the transformation equation we use is y equals a times b times x minus h squared plus k. So identifying the pieces of the equation that are different than that parent function, since the 5 is being squared, it would be a horizontal transformation, so that's our b value. So since b is 5, that means we have a horizontal shrink of 1/5, because everything that is a horizontal transformation is opposite from what it actually looks like in the equation. The 3 would be our h, so we are shifting to the right 3 units. And the plus 7 is our k, so we are shifting up 7 units. Number 4, to graph, or to answer the questions about number 4, y equals 4x squared minus 8x minus 12, we're going to put it in the calculator. The very first question asks what form is the equation in. Well, since this is ax squared plus bx plus c, this would be standard form. So I'm going to start by plugging this into y equals. And hitting the graph button. So the first thing that it asks for is the vertex. So to calculate the vertex, I go to second, trace. And since this value, or since this graph is a parabola that opens up, I'm going to have a minimum. So I'm going to scroll to the third option and hit enter. the left bound has to be on the left side of that minimum value. And right now the minimum value is just off the screen. So as long as the cursor's on that left side, I can choose that point and hit enter. Now it asks for the right bound, so I need to scroll to the right until I know that I'm past that minimum point. Hit enter. And the guess can be anywhere in between those 2 points. So my minimum value is going to be, the calculator says 0.999. We're going to round that to 1. And the y value is -16. So our vertex is at 1, -16. Is this a reflection over the x-axis? No, because the parabola still opens up. That a value is positive. The y-intercept, if we hit trace, we should be able to trace back to where x is 0, y is -12. The x-intercepts, they look like they're going through integer points, so we can check that with the table. And we're looking for where y is equal to 0. So that happens exactly at -1 or at +3. For the rest of the information, as long as I have a rough sketch of this, I can determine increasing, decreasing, domain range, and end behavior. So the graph looks something like this, with the vertex at 1, -16. So increasing is going to be on the right side of this parabola, where the y values are going up as the x value is going up. So we will describe that from 1 to infinity. The decreasing portion of this parabola will be on the left side of the vertex, where the y values are decreasing as x increases. That'll be from -infinity to 1. The domain for all of our parabolas is going to be all real numbers. The range is going to be from the y value of the vertex, and it's going up, so we have a bracket at -16 going up to infinity. The end behavior, because this parabola opens up, both sides will be approaching positive infinity. Number 5, using the equation y equals -4 times x minus 3 squared plus 5 to answer the following questions. What form is the equation in? This is in vertex form, so we can do some of these things without the calculator. The vertex would be at hk, so our h is going to be 3, k is 5. Is this a reflection over the x-axis? Yes, because there's a -a value. The axis of symmetry is always x equals h, so our h is 3. Since it's a reflection, it will open down, which tells us we have a maximum value at the vertex. So remember, the maximum value is the y value and then we can describe where it happens on the graph, which is at x equals 3. Increasing, always reading left to right, the increasing would be the left side of this graph. So from negative infinity to 3. The decreasing portion would be the right side. So that would be from 3 to infinity. Domain is still all real numbers. The range this time, because it opens down, will be from negative infinity, and the highest value, y value, is at 5. And we have to include the 5. The end behavior on this one, since it opens down, both will approach negative infinity. And we can list our transformations based on this equation. So the negative that is in front of the equation will be a reflection over the x-axis. The 4 that is the a value will be a vertical stretch by a factor of 4. We are shifting to the right 3 and up 5. Number 6, given the axis of symmetry and 2 points on the parabola, find the standard form of the equation that represents the parabola. First thing we're going to do is sketch a graph so that we can identify at least one other point on the parabola, because we have to have 3 points to graph a parabola. So my axis of symmetry is x equals 3, so that's that vertical line. Now I'm going to plot the point 2, 2 and the point 5, 5. Now, since the point 2, 2 is 1 unit away from the axis of symmetry, I'm going to reflect that across. So I know I also have to have the point 4, 2 on the parabola as well. You could also use the point 1, 5, because that's the reflection of the point 5, 5 across that axis of symmetry. Now, to set this up, we're going to use the matrix to solve for our A, B, and C. So, to set up your matrix, each column, the first column will represent x squared. Second column will be your x value. The third column is 1. And the solution matrix will be your y value. And then each row of the matrix represents an individual point. So using the x and y values from those coordinate points, I can fill in the pattern. So 2 squared is 4. X is 2. This guy's 1. And my y value is 2. For the second point, my x value is 5, so x squared is 25. X is 5, 1, and the y value is 2. For the third row, my x is 4, so x squared is 16. X is 4, y constant is 1, and y is also 2. I'm gonna go ahead and fix this. I miswrote that, so 5, 5 should be our second point. Now we're going to use the calculator to run the matrix. So that is under alpha zoom. We need a 3 by 3. And the inverse button. And then alpha zoom, I need a 3 by 1 matrix to put the y values in. And we get 1, negative 6, and 10. So A is 1, B is negative 6, C equals 10. So our standard form of our equation will be x squared minus 6x plus 10. Number 7, write a quadratic equation in vertex form for a parabola with the vertex 4, negative 6, and then it goes through the point to negative 4. So the process for writing this equation involves algebraically finding A. That's the piece we don't know. So vertex gives us the h and the k value. The point gives us an x and a y that we can use to find the a value. So using this format of the equation, I'm going to plug in x, y, h, and k and solve for a. So negative 4 is y, x is 2, h is 4, and k is negative 6. I'm going to start by adding 6 to both sides. And I can go ahead and do the operation inside the parentheses. So 2 minus 4 is negative 2. So I have 2 equals negative 2 squared is 4. And then I can divide by the 4. Two fourths reduces to 1/2. Now I just need to write the equation. So I'm plugging in the a, the h, and the k because those are the things that make this specific to this situation. So y equals 1/2 x minus 4 squared minus 6.